Hi, this is Professor Kleitz. The last section in Chapter 16, Section 6, deals with magnetic and optical storage. The types of memory storage discussed so far have been based on semiconductor material. They have relied on turning transistors on or off, or storing an electrical charge on a capacitor or a floating gate of a transistor. So in this section we're going to talk about magnetic memory and optical memory. First of all, the floppy disk and hard drive. Before the advent of flash memory, most common removable magnetic storage for the PC was on a floppy disk. This was way back in the probably the 1990s or so. It consisted of magnetizable medium that spins inside a rigid plastic jacket at a speed of 300 RPMs. The disk drive that holds the floppy disk has two read-write heads, one for each side of the diskette. They are used to record a magnetic charge to or read a magnetic charge from the diskette. Up to 1.4 meg of data can be stored on a double-sided diskette. Back in the day, that was quite a bit. The beauty of the diskette is that I should say, that it could be removed from its drive unit and used at a different location or filed away for safe keeping. Additional diskettes can then be purchased for less than $1. So this was a big step coming from the old back in the 1980s when we had magnetic tape drives where you would have to spin through an entire tape from one end to the other to retrieve data. But the hard disk took it one step further. The hard disk drive, the highest speed magnetic storage is achieved using a hard disk. This disk system is not considered a removable medium like the floppy, but instead it uses a series of rigid platters mounted in a sealed unit inside the PC. Its recording method is similar to the floppy, except that it uses several two-sided platters, usually 3 or more, to hold magnetic data, and has one read-write head for each platter surface. Because the platters are rigid and mounted in a permanent housing, their tolerances are more precisely defined, allowing for tighter spacing between the bits. This also enables the disk to spin at a much higher speed, thousands of RPMs. Storage capacity of hard drives are up in the high giga range. So figure 1624 shows a magnetic memory. This could be either whether it's a floppy or a hard drive platter with one of its read-write heads. So the read-write head, the pickup and the delivery of the magnetic charge is on a retractable head. Now it can start at the outer edge or go all the way to the inner edge as the disk is rotating around. So the disk is spinning around and the read-write head might be near the inside or further out anywhere along the way. Now to read and write, you have magnetic flux lines going around a read-write head electromagnet, and if you place the plus on this side, you'll actually cause the flux lines to travel clockwise through this core and create a north-south magnet in this small area. And so what I've shown here is over on the left side, it's a north on the left to south, that represents a 0. South to north represents a 1. South to north represents a 1. North to south a 0, and so on. Now before the read-write head was magnetized the material, you have random or unaligned media particles that have to be aligned in order to be designated as a 1 or a 0. And this is the top surface. We'll do the same to the bottom surface. So after the information is written out to the substrate, as the disk spins underneath this read-write head, the process is reversed, and if it's a north-south like it is here, then that represents a 1, whereas if it was a south-north, it would represent a 0, and so you can read the data back out again. So the disk speeds back in the old days, the floppy was around 300 RPM, and the hard drives are 3600. They're up way faster than that even today. So the spinning speed dictates how much data you can store on the disk in a second or in a millisecond or a microsecond. Also, the density has gotten deeper or more and more dense. The tracks per inch in this direction was only about 135 back with the floppy. Now there are 3,000 and more different tracks per inch on the hard drive. And then the bits per inch in this direction with the floppy were around 17,000. With the hard drives, they're more than 50,000 bits per inch. But now let's shift our attention to optical memory. This would be the CD, the CDR, the CD-RW read-write, and the DVD. Music CDs have been around since the late 1970s as a digital medium for the storage and playback of analog music. In the mid-1980s, they were adopted for storage and retrieval of digital computer data. Their data transfer rate is generally not as fast as a hard disk, but manufacturers are constantly improving the speed. Because it's a removable media and the capability of holding up to 650 megabytes of data that's on a CD, most new operating systems and application software are provided on CDs and on DVDs, as we'll see shortly. Now, a CD and a DVD is a single continuous spiral track. So it starts in the beginning and spirals outward. I don't know if you can see this. Spirals out, 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 out. So the beginning of the CD is in the middle and it spirals out to the outer edge. There's up to 16,000 tracks per inch. The actual polycarbonate wafer, which is a substrate, is going to have the ones and zeros that we need to interpret our digital signals, and they are called pits and lands. So a laser beam is actually shone down onto the substrate, and if it burns a hole in the substrate, that's called a pit. That will be a 1. If it does not burn a hole, that's called a land, which is a 0. And so as we're reading from right to left, that would be first of all a land being a 0, and then a pit, pit, land, 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 and so on. So these are our ones and zeros that get imaged inside a CD and a DVD. And this imaging is done right inside the aluminum alloy coating. And the DVD construction is real similar, except the density is way up over several gigabytes. They used to be 4.7 gigabytes, and then they improved to 8 and then beyond. And now there's the advent of the Blu-ray player, which is real similar, but the density is even higher, the speed is faster, and the number of bytes that can be stored on a Blu-ray are significantly higher. So that concludes Chapter 16. Next, we'll start talking about microprocessors and microcontrollers in the last 2 chapters.